Hi, I'm an old guy and I do maths. And here we have, badly drawn, as usual with me, the graphs of y equals sine x, which is the red, and y equals cos x, which is the black here. And we've been asked to find the area of the shaded region, which is between 2 points of intersection on these graphs. So the first thing that we need to work out is what is this point on the x-axis and what is this point on the x-axis. So they are points at which clearly the sine of x is equal to the cosine of x. Now, if we take a look at a triangle, which I hope you're familiar with, you use this one for working out trig ratios. The sine of x, if we put x in there, the sine of x is the opposite over the hypotenuse, and the cosine of x is the adjacent over the hypotenuse. So, what is this angle? Well, it's 45 degrees because we have an isosceles triangle here with a 90-degree angle in here. So, it is 45 degrees, or pi on 4. Now that is this point here on the x-axis, pi on 4. Because my drawing is so poor, we need to note that this is pi and out here is 2 pi. Now, in any decent drawing you could apply symmetry, but this is pi plus pi on 4 here, which gives us 5 pi on 4. So we have the parameters between which we are looking for these. Now, there are a couple of ways in which you can approach finding this area. Again, because of my poor draftsmanship, it's not apparent that this area here is the same size as this area here, but it is. And you can use symmetry to figure out that. You can find the area between here and here underneath the cosine, and you can find the area between here and here underneath the sine, and you can subtract one from the other and then double it, and that should work. I'm going to go more by what's really become the textbook version of this, and it's a tiny bit more, well, it's not as fast, put it that way. Okay, so we have our two values of x. X is equal to pi on 4 or 5 pi on 4. Okay, so let's set up our equation, which is the equation of a definite integral. Okay, so the area is going to equal the differential, rather the antidifferential, the integral, of 5 pi on 4 here, pi on 4, and we're going to have sine of x minus cos of x dx. Okay, so let's get to work on that. What do we need? We need the integrals of these, which are negative cos x, and this would be positive sine x, but we have a negative here, so it's negative sine x. And we'll just put those values between square brackets. 5 pi on 4, pi on 4. Now, when we get to work all this out, there's quite a bit of writing. So let us start off. We have negative cos 5 pi on 4 minus sine 5 pi on 4 minus, and this is really the textbook version of this, as I say, this area here has magnitude, so we need to make sure that we've got sufficient negatives in here so that we get a positive answer. We get a positive answer to this. Cos pi on 4 minus sine pi on 4. Okay, well, what do we know about all of these values? Well, what we know is that the values of, if we take a look at this graph, we can work off this graph. The values of the sine of pi on 4 and the cosine of pi on 4 are positive, and these values here will work out to be positive courtesy of the double negatives here. So, what is the cosine, the negative cosine of 5 pi on 4? Well, it would be pi plus pi on 4, which puts it in negative territory for a cosine, but because we've got a negative here, it's negative negative. So what is that? Well, it's 1 on root 2. That's that. What is the story with the sine of pi on 4? Well, it's exactly the same. And again, we're dealing with a negative negative. If I do this very quickly, I can show you what I'm talking about. We're looking at this area down here, and both sines and cosines are negative in here, but because we've got minus this, it'll be minus minus, which will give us a plus, which will give us 1 on root 2. And it's the same story over here. The double negative will give us plus 1 on root 2 plus 1 on root 2, which will give us, I think, 4 on root 2. Now that is the area between these two curves. The question is, can we simplify this in some way? I think this is a reasonably respectable answer, but yes, we can rationalize this denominator. So let's go ahead and do that. So what we get there is 4 root 2 on 2, which if we divide 4 by 2, we get 2. So the answer is 2 root 2 square units, or units squared. We don't know what the exact measurements were. Anyway, that is that problem solved. I hope you found that interesting and useful. If you did, please like and subscribe, and I will see you next time. Bye.